In this first video for Chapter 6, we're going to look at how to use our calculator to find some z-scores, going from less than, greater than, in between two scores, and also how to find the z-score given that you already know the probability. Um, if you're given a z-score and it says find the area of the shaded region, in your textbook there's a pull-out card, and what you can do is look it up on the pull-out card and follow it like a stem and leaf chart and into cross sections, and then you'll get your area in between the two shaded regions. However, that is a little, that's not the one. It's a little time consuming and it only goes one direction. So what we'd rather do is use our calculator to do this for us. And we use binomial PDF in the last chapter. In Chapter 6, we're going to use normal CDF. In 5, we always use the PDF. In 6, we always use the CDF. And so we'll go into second vars because we're looking at it now a normal distribution. And you'll see it right up top here, normal CDF. You're going to pick that and pull it out to the main screen. And you put it in the upper and then the lower z-score, and then you put in the upper z-score. If you don't have a bottom z-score, it is a negative 9999, comma to your upper, which here is a 0.12. On the newer calculators, you'll see lower, you'll see upper, and then you'll see your mu and the sigma signs, that one has a 0 and one has a 1. Just leave that alone. It does have some cool features in it, but you're going to need to know how to convert a z-score later on anyway. So I would not mess with those at all. I would just put in my lower and my upper and then pull it out to the main screen so it looks like this. And when you hit enter, there you go. You'll get the area of the shaded region. We usually go 4 decimal places, so 5478. What I like about the calculator is that now if I want to talk about greater than a negative 0.123, my calculator can do that, where my chart cannot. And so if here's my normal curve, and I want to find the area greater than a negative 0.123, here's my negative 1.23. So it's got to be one of those two, right? And then you want greater that from that. So from there up. So we're talking about this graph right here. And so now to find this probability, to find the area of landing in this region, I will go back to my normal CDF, which is second vars, normal CDF. And now my lower limit is given. I have a negative 1.23, but I don't have a stopping point. I don't have an upper, and so that's positive 9999, and I'll close that out. And I have a 0.8907, 0.8907. Now, if you were going to use the chart, what would happen is you would find this over here, you would find B, and then you would have to subtract that out of 1 to get the other side. Because when you have one z-score, it's basically splitting it into two halves. The chart will always give you the left-hand side of it, so if you want the right-hand side, you'd have to subtract from 1. If you had in between two z-scores, then what you would have to do is find one z-score area, find the other z-score area, and subtract them so that you're left with the overlap. So it's now a 3-step process, where in the calculator it's still just 1. If I want to find the area of the shaded region in between a negative 2.26 and a negative 1.49, then I would be looking at that. And it's a little tricky because that's actually shaded over here, where it's white over here. And in my calculator, I'll do the same thing. And I don't need to go into second vars over and over and over again. If it's the last thing I did, I could hit second enter and pull that up and then just write over this. Where now my lower z-score is the negative 2.26, comma, my upper is now a negative 1.49, right? Because the bigger the negative number looks, the smaller it actually is. And there's your probability, 0.0562. Light years easier than having to use the chart to find anything. The other thing that you may want to do is now you're given the area and you want to work backwards and find what z-score would have that cutoff. It's kind of like what we would do with percentiles. What score would I need to be in the 90th percentile? What score would I need to be in this list to be at the 75th percentile? This is basically saying like what score would I need to be at the 0.90, 91-ish almost percentile. So what we're going to do is use a nice little feature on here that's under second vars called normal inverse norm. Inverse norm. Now inverse norm, unlike normal CDF, only goes left from right. So I want to know the left hand side here. So that's good. So I can pick that out and then put this in. And a 1.34 for a z-score would have an area to the left. Now, if I wanted to know the area on this side, like let's say they were giving you this right-hand side over here, you would have to say, oh, well, that is this area over here and work backwards from that. So for inverse norm, you would have to put in the left-hand side. You can only put in the left-hand side, or else what's going to happen is it's going to give you the opposite z-score. I don't think I have any of those in here. I guess not. No. Now, in the next section, which is 6.3, I take it one more step. Now they're going to give you data and say, all right, convert it over to a z-score, which we've done before, and then find the area of the shaded region. And so find the area of the shaded region. This graph on the right depicts IQ scores of adults. The scores are normally distributed with a mean of 100 and a standard deviation of 15. These tables are our z-score tables, which we're not going to use, but I'll show it to you in a minute. This is not the z-score. You can't have it, well, you could have a z-score of 80, but you never will, and it certainly won't be over here on this side. It would have to be a negative 80. So what we're going to have to do is take this 80 and say, well, what's that in terms of z-scores? And so let's find out. 80, which is my x, minus my x bar of 100, divided by my standard deviation of a 15, gives me a z-score of a negative 1.33. So in the IQ world, the cutoff is, we call it an 80. In the z-score world, we call it a negative 1.33. And now I can find the area of that shaded region on my z-score chart. If I wanted to use the chart, I would say, all right, a negative 1.3, so you would come down to here. Come on, there we go. And then it's like a stem and a leaf, so you just go over to here and you'll get your area, 0.0918. And so you can use that since it's the left-hand side, or as I much prefer, to use my handy-dandy calculator and say from negative infinity up to the negative 1.33 and get my same answer when I round, 0.0918. And that's what you would need to do in this section, is just convert a bunch of different scores and work from that. Actually, let's talk about that one. If I can get back to it. There we go. Here it says, okay, we're talking about the IQ scores again, and I want to know the IQ score that I would need to have to be in the 65th percentile. That's what that says. I can find out what that is in the z-score world pretty easily. I can pull this up and say, oh, second vars, inverse norm. What z-score would I have to have 65 to the left of it? A 0.39. So this x is a 0.39 in the z-score world. But that's in the z-score world. I need to figure out what's going on in the IQ world. Nobody says I have a z-score IQ of 0.39. So let me see if I can write this. My z-score formula is z is equal to x minus my x bar. I'm doing surprisingly well without my pen tablet. Divided by my standard deviation. Well, I know my z-score. It is a 0.39. I don't know what x I'm talking about, but I know that my average was 100. And I know my standard deviation, whoops, I'm a little slanty on that, huh? It is a 15. And so now I can solve this. Okay. I will cross multiply, so 0.39 times 15. Z-scores go 2 spots, probabilities go 4 spots. So I get a 5.85. Big 5, little 8, I guess. There we go. And now I just have a little one-step equation, so I'll have to add the 100 to both sides, and I get a 105.85. And my math lab says only go one place, please. So 105.9. These view and examples are actually pretty good. You might want to go ahead and check those out, and you can print them out, which is kind of nice. And that's what you're doing through most of here. These ones at the end that are a little bit wordier are just using percentiles or saying percentages instead of drawing the little table for you. So like third quartile, you're talking 75% to the left or 0.75 to the left. Sometimes they talk about it as the top 25%. This is what you're doing in your Chapter 6 lab that's set up like a quiz, but it's just a regular lab. And the next part of this is a little bit different, and I'll do that in another video of how to deal with the central limit theorem.